Well, hi, good morning, and thank you for joining me in my shop here. It's February 26th, and it's normal. Normal weather. Everything's normal. It's right around zero. That's normal for this time of year. So, what about this radio now? So, a little bit surprising to me, it's still not working with any decent volume. I really thought we would catch something by looking at the tubes, but no. So I could start replacing capacitors. I could do that in some kind of sensible way. On the other hand, I could poke around a little bit with the radio and try to figure out, try to localize the problem, or maybe even pinpoint it. The thing about it is, it could really be a cascade of weaknesses here, and in their summation, the radio is weak. But if each individual stage, if you like, not particularly weak. Now, is that really the case? No, I don't think so. I really think there is something wrong in here that we can find. So I think the first question I would have is, we can split the radio into two parts. The radio part that's dealing with the RF signal, on your antenna and the high frequency stuff you can't hear. And then at some point, the radio, that is converted to audio, and then the other half the radio, roughly, is dealing with the audio circuits. So I'd like to start there with the audio circuits, and most importantly, the output of the radio. I think the output of the radio part of the radio, the RF part, is good. Don't know that for sure, but we can look at this, and then we can also check through the audio circuits and see if the audio is disappearing somewhere along the lines there. And just looking at the speaker that's put in here, what is this? This looks like a patch. This is a hole. This is a finger hole right here. If somebody's finger's gone through it, and it looks like, I don't know, is it an attempt to repair it or not? By the way, having a speaker just floating out here like this, not particularly good. When we get around to it, I'll explain why speakers do better in boxes than they do just out in space, like that one. Okay, so a good place to start would be looking at the schematic and just getting familiar with the audio circuits, and talking a bit about the detector and the division between the RF part of the radio part, and the audio part, which is just an audio amplifier, basically. Yeah, let's take a look at the schematic here. Okay, so I mentioned the radio can be thought of in two parts. It can really be thought of in a number of stages, 6 or 7 stages, or 5 or 6. But let's think about it just in two parts. So again, the first part is a part that's dealing with the radio frequency signal. It's coming in on the antenna. It's being converted to a different frequency in through the middle of the radio. But that ends. The RF kind of ends right around here. So to the left of where I'm marking it, it's all RF, and to the right, it's all audio. And this is the dividing line, and it happens with these two diodes. You can just see inside the tube symbol here. In this radio, the two diodes are just connected together as if they're one big plate in here. And what's happening is the radio signal that's been developed through the front part of the radio is being rectified by these diodes. And once it's rectified, it becomes possible to recapture the audio signal and do away with the radio signal. We don't want it anymore, any high frequency radio stuff. So you'll usually find a capacitor like this one, a head of a resistor like this one, and this forms a filter, and this is killing the RF. This is going to eliminate or reduce greatly the amount of RF that's in this line, and what remains would be the envelope of the RF, or the audio stuff, the actual information you're trying to recover from the signal, and that's going to be fed to the volume control. This is the volume control right here. It's very, very simple. It's a very simple radio in design. So we can go to this location here and we can find out what kind of signal is coming out of here, the last stage of the RF signal. And we can find out how loud it is here. We can also find out how loud the audio is being fed into the volume control. The radio output is at maximum all the time. It never ever goes down. So you can think of it as blasting onto the volume control, and then some portion of the blast is picked off by the volume control and sent on its way to the speaker. Ultimately, where are you, speaker? Way down here. So we can look right here at the input of the volume control and see what's happening there. What kind of audio is there and what kind of RF is left there. Really, it's the audio we'd be interested in. So we can do that easy test. I have a signal tracer. We can listen to this point and see how loud it is here. Likewise, we can do the same thing. We just follow the signal along. If it's loud here, why is it not loud here? And we could find the spot where it's kind of fading out. A couple other things we could do. We could look at the bias voltage on this tube. It's a little bit tricky to read a bias voltage. Depends how the bias is created. I believe it's a self-biasing arrangement here. Last time I looked at this, it's a little bit unusual, I think, for an output tube. So maybe I've got it wrong and more needs to be discovered about how this is really working. Yeah. Okay. Let's listen to the volume control. What's being fed to the volume control? That's the question we have. Okay, let's give this a try. So we're going to want to access the volume control leads. Now I see the radio is setting down right on the tuning wheel here. That's not so good. Not so convenient, but I think if I'm aware of it, I can just kind of tip and tune. Okay. So there's no power coming to this radio yet. Let's take this out of here. Okay, volume control is here, and there is going to be three terminals up here, 1, 2, 3. The middle one is the one that's sending the sound onward. The two outer ones, one of them will be grounded, in most radios, grounded, and the other one will be the one that's receiving the signal from the detector. So, what we see here is a black wire coming off this terminal. Almost certainly that's a grounding wire. It's very dark in there. A little more light. It's really hard to see what's going on there. So this is a replacement for the original filter capacitor, and I've done a replacement of one of them. It's way up in here. You can hardly see it where my thumb is. But this guy's right in the way here for me to see clearly. Okay, I see clearly. So the black wire is coming to this terminal here, and that's probably a B- terminal. It's a little tidbit of bare wire coming out of there. That's what I'm trying to see where it goes. It's probably goes nowhere. let's put the close-up camera on there and get a better look at things, because as it stands right now, I cannot see. Okay, so the autofocus will be on this camera, which might be a bit of an annoyance. So what we're trying to see here, yeah, that's annoying. Come on, camera. Right, there it goes. So I'm going to fix the focus on this camera, because it's going to drive us nuts. So let me set it up about like this. And just bear with me here while I call up the dialog box for the camera, and I'll freeze the focus where it is right now. There. Okay, won't have focus trouble now. Let's go back up here. So you see the red capacitor is a replacement capacitor. That's coming from the center terminal of the volume control. Yeah. The wire we're following is the black one. It goes down underneath the capacitor. And this is where I was having a lot of trouble seeing it here. Okay, so the piece I saw sticking out turns out to be the lead to a resistor. It doesn't look particularly well soldered, that terminal, does it? Now the output from the red capacitor there, let me get a poker. Need a poker. See, he's just what the last guy did was he cut the old component out, kept some of the wire from the leads, and then tied the new component to the old wire lead. Something I do a lot. And it's going ultimately way down under here. That's a vacuum tube pin. Should make some sense. So the audio is being sent from the volume control, the variable part. What about this bit of solder here? It's probably soldered well enough, you know, to work. It's just not. It needs a lot more solder to cover it all up. So I don't think there's anything particularly wrong here. I don't think. It's just underneath there. So we're going back to the black wire, right? The black wire. Where's that black wire? Black wire coming around the back here. And it's connecting to this terminal that is, well, could that be the end of the, so this is supposed to ground the volume control. It's probably good. I'm chasing nothing here. Okay, now, so if we look at the, this wire is not connecting here. No, it's not. Oh, you can see in the camera quite clearly, but when I'm looking with my eyes, I'm seeing something that looks a little more. Anyway, not to worry about it. Ooh. Okay, wasting time now, Jim. Looking at this switch soldering situation. I think this wire should just be bent a bit. Just improving the clearance in here. Okay, enough of that. Everything's good. Why am I fiddling around so much there? Didn't really need to. Okay, so what we're going to do is we're going to use this device here. We're going to set this to listen for audio. So it's an audio amplifier. This has a couple volume controls on it. This is the volume at the speaker, and this is the input control. Well, it has a magic eye. It's getting a little worn out. Slowly coming on. We don't need the magic eye. This is the ground lead. Okay, ground lead. Put the ground lead on the chassis of the radio. Won't bother looking at this anymore. All I'm doing is turn the volume up and down on it anyway. Turn it down, in fact. And we're going to practice. I don't think you need much practice, but I want to go on the input side of the volume control. It's going to be on this yellow wire here, which is going up to the terminal. So that's what's going to the volume control. And then if I move it to here, that's what's coming out of the volume control. We already know kind of what comes out of the volume. Well, we don't. We don't know for sure. We don't. Okay. We're all set here. We're on the right band. Radio is on. There we go. So what am I expecting to find here? I'm expecting to find, my guess, full volume at the volume control, and the problem with the quiet output is beyond the volume control in the audio circuits. That's my guess. And it is just a guess. Okay, so we're running with 100 volts here. See if we can find a station. Now the antenna maybe, this is a directional antenna. Which way is the capacitor? I can't see it, but I know that this is backwards, so we're at the low end of the. Any station. Okay, rotating the antenna. Okay, I'm gonna augment this. I'm gonna send a signal from my outdoor antenna into the radio using the antenna connection here. See if we can't boost it up a bit. Ooh, no sound? Oh yeah. Turn down the radio, so the volume was right up. So although we could hear it, it required the volume to be full up. Now, what we'll do is we'll take a look at what's going into the volume control. Why so quiet? Oh, I know. There we are. And the attenuator switched on. Okay. Top of the volume control. That's right here. This is the input to the volume control. Where'd the radio go? Well, I was expecting to hear basically the same thing we heard coming out of the speaker. What happened? Hey, where'd the radio signal go? Huh. Ooh, what's that? Got me as to what's going on here. I did discover last night, to my disappointment, my outdoor antenna has become intermittent. Somewhere along the line, literally along the lead-in line, something is not working out right. So it's an intermittent come and go problem, and I haven't tracked it down, and we're using the same antenna here now. So perhaps it's coming and going. Let's leave it here. I'm going to turn this down and listen again with the this guy. Okay, the problem is I've connected the ground inappropriately. It shouldn't be here. It should be connected to the B minus. This radio is turned around a little bit. We might want to connect it to the So what I noticed is the power supply filter capacitors are connected backwards or upside down from what I normally encounter in these radios. So this one, the engineers took a little different approach with it, and I could easily, because of my paradigm thinking, think something that's not true and then damage some equipment or something somewhere. So we're going to look for a voltage between. This should be B minus here. Well, this is B minus. I can hook up right here. Yeah, why not? Let's just check something. So B minus to the positive side of the filter capacitor. 30 volts. Only 30 volts, and we go on the other side. Not zero. Yeah, see, there's something funny going on here. Funny, haha. I would have to study the schematic really carefully. Let's just switch these around just for fun's sake. And this is the capacitor I installed. 30 volts. Well, this is something I haven't looked for yet, and that is correct voltage. Correct B plus. That could explain low output. So B plus should be in this radio 150, 140 volts, maybe a little less. No more than 160. It's not really possible. So what's happening here that the filter capacitors have such a low voltage on them? I've never checked this till now. Let's try it again. I'm on the 60 volt DC scale here. On the positive end of this, we get 29. And the positive end of the other guy here, 29. That's probably the real problem there. Never mind everything else. Lack of B plus. Now I do have it running on just 100 volts here, but that wouldn't account for that. That can't account for that. Let's just check it. Make sure. Again, relying on this as a ground. Let's see. It's pretty sure this must be at B minus level, because there's a capacitor coming from here to the chassis. This capacitor wants to connect to the B minus, so that's what this got to be. I gotta have this right. Okay, now we're up to 32 volts. Let's look on one of these tubes, just see if I'm out to lunch here. So we'll just go around. One of the pins, at least one or two of the pins on here should have 100 volts anyway on it, and we'll just find it. There's the B plus, 31 volts. That's probably the grid voltage. That's probably a screen. Probably screen and plate, or plate and screen. That's the problem. That's why this radio's quiet. It's got no voltage. So vacuum tubes are really particle accelerators. And it's fun to think of them that way. You keep that in mind all the time, that you're operating a device that's using atomic particle accelerators in it to achieve the result. They use the accelerating flow of particles to create amplification effects and the like by throttling that flow. Interesting stuff. Why low B+? I'm going to go consult my coffee cup, and we're going to look at the schematic and try to come up with a theory of why the B+ may be low. Then we'll see if the theory is correct. Okay, let's take a look at the schematic here. So I'm reading 29 volts on these capacitors, and they're coming right off the rectifier tube here. So we should be seeing the highest voltage, and it should be around 130, somewhere in that range. What could cause the voltage here to be low? Short circuit on the far side, somewhere beyond here. That's not terribly likely. Wow, what's this? R9. What's that doing in the plate circuit? R9. 22 ohms. Not exactly sure what it's here for. 22 ohms, not much resistance. Might be protecting the tube on turn on when it first has to charge these capacitors. It'd be a heavy current drop, not for very long though, just a fraction of a second or a second or so. Maybe that's what this is here for, just to reduce that a little bit. R9, 22 ohms. So we got to find this and find out what's going on with R9. That's our first target. Because if this has gone open, the whole radio would be dead. Or if this has gone way high, it's dropping all the B+. Here. It's not getting anywhere. R9. Half watt. You know what I just remembered? I just remembered this funny resistor situation. Let me flip this around here, a little easier to look at. Probably a better way to have it. This arrangement here. What is going on with this? Let's take a closer look at it. See if we can read the values off the resistors. Well, that would be 47. Black is nothing. That's a 47 ohm resistor, right? They're trying to get to 22. So you got 50 there, and the other one, I wonder if the other one is exactly the same. The other one is what do you make that out to be? Green. I'm going to guess black because I can't really see it. So green would be 55. So we got a 55, and this would be also roughly a 50. So you're looking at 26 ohms in here. It's pretty darn close to what it showed on the thing. That's got to be what's going on here. And this, the two of them together are to provide. I was going to say is to provide the dissipation, but you don't need two of these. One would do it. This is a situation where this is all the guy had. Those two resistors, so he decided to use them. Not necessarily a problem. Not necessarily a problem at all. Let's measure them. See what we got here. $22. $27. I hardly think that would cause the B+ to fall so much. We can look at the voltage drop on these resistors. That's the next thing to do. should be, well, you wouldn't want very much on there, that's for sure. We've got to switch on the radio again. You would only want it to drop, well, really you don't want it to drop anything. That's really what you want. But of course, you can't have a resistor in there and not lose some B plus voltage. Okay, let's check again, see if we still have the same anomalous amount. That's the negative side. And this is the positive side. 30. And down here. And I'm going to read right across one of these capacitors because maybe I'm getting a false reading here. Let's go right across. No, there's no false reading there at all. Definitely 30 volts. Okay, how much is being thrown away on these resistors? .3 volts. The problem does not lie there. Now I only check for B. Well, they're right there. I was going to say only check for B plus on 1, 2, but it's right in the supply. It's low. This is a little odd. This is definitely a little bit odd. I'm not sure what I should be doing next here. I think probably I should stop and go drink some coffee and ponder the situation a bit more. To turn this off before I forget. Yeah, that's kind of weird. There's really just a rectifier tube. I tested the tube good. Okay, yeah, coffee. I will consult the coffee cup. Okay, well, I think before going any further, we have to be sure the rectifier tube is good in this radio. I've tested it once. I think it came out okay in the test. But I have a different tube tester sitting here beside me now. So let's try the same tube, different tube tester, and just see if it turns out this guy can't do the job anymore. If you look at it, at the plates inside, you can see some white that is formed right on this part of the inside plate. A little bit on the other side, and it's a little hard to see. I realize from all the reflections in here, but just a little bit of white there too. The significance of that, I got no idea. I got no idea if it does it mean anything. I don't even know. Okay, let's fire this guy up here. And my tripod is trying to escape once again. Oh boy, oh boy. There. Okay, let me just douse some lighting in here, and then I'm able to see the reading dial. Now I can barely read these things. 35Z5. 35. Yeah, I can't see. That's dumb. A dumb situation here. $35Z5. Here we are. 35Z5, yes. Okay, so 35 volts. It's a rectifier, so this doesn't matter. Bias doesn't matter. 07003. 07003. 0610. 0610. 23 and E. 23. Okay. We're all set. How come the light isn't on? Oh, because of this. Here we are. There we go. Z5. We can set it in here so it warms up. My guess is this is going to test out just fine, just like it did on the last test. And we'll know for sure it's not this tube. So in this case, this is a rectifier tube, so the pointer has to come up above where my finger is right now. You probably can't see it, but there's a little area on the dial here that says rectifier is okay beyond this point, just a little ways beyond the middle point. Then I'll be pushing the rectifier test button. Okay, doing the short test. No shorts. That looks really bright here, much brighter than it does in the radio itself. Ready on the test. Okay, so it's way up in the good. Way up there. That is really glowing. Got those electrons just hopping away in there. Yeah, so notice in a rectifier, there's not much gap between, well, the plate and the cathode. I mean, it's almost paper thin in there. And the gap is small to encourage heavy current. And this is actually it. Look at this tube. Let me pull that out again. You see here it says Jan on it. Jan means this meets the standards for the American Army and Navy. Joint Army Navy. Jan. So this would be a better than regular commercial tube for some reason. Something about it would make it a little better, more rugged or something like that. So if this is not causing the problem, what no. Both capacitors show. Let's look at the schematic here and talk about this a bit, because this is getting to be a little strange. So I read both capacitors. Well, of course I read the same. Wait a minute. 1 minute. No, I'm reading the wrong side. So they're connected together through this coil. If both of them are reading the same voltage, 30 volts, it's got to be way low from where it should be. How can this be? If this coil were open, then you would get no voltage. The radio would be dead, and you'd get no voltage on this side. You'd still see voltage over here, though. That's certainly not the case. We get it on both sides. The coil must be good. What if the coil were shorted right out? What if there's just a wire across here? Well, you'd have a lousy filter. You'd have these two capacitors just in parallel. You'd have a lousy filter and a humming radio, unless you put big capacitors in here. Maybe whip a resistor in here. You'd have a typical power supply for a later radio that doesn't have a field coil speaker. I'm just talking kind of randomly here, hoping that something will pop into my head and I'll go, oh, I know what it could be. So if the voltage is low, it's not due to the rectifier, and the supply is proper, which it has to be. And this resistor is fine. R9, just double check. It's supposed to be 22, and I'm measuring it a little bit higher. That's not enough to account for the fact that it accounts for nothing, because I did measure the voltage drop. There was nothing there. So where's the voltage going? Like, how does this work? So another possibility is a short on the output side of the power supply is pulling the voltage down. This is probably the more likely cause now. So what could do that? Lots of different things. Let's just see what's early on. So this is the plate feed to the output tube, and this side's the screen feed here. So you have the screen current not passing through the coil, but the plate current is passing through the coil. I don't really see much of what could happen here that would pull the voltage down. So we carry on. If we follow this lead here, we're getting into the rest of the tube. So this is the, wow, really hard to tell. This is the plate supply here. It's going to be the plate supply here too. No, the plate supply should go through the coil here. Same thing over here. Yeah, it's just, yeah, there's the plate, there's the wire. Inside, there it is, yeah. Well, what could pull it down here? There's no components, like there's no capacitor to ground here. Or did I miss it? Let's just follow it again. So this goes to the, probably to the screen here, and it's just basically an open circuit. Can't pull current. Wow, I'm really stuck here. I'm just trying to even come up with some explanation. What's this one here? Let's see. This is on the other side. This is the grounded side of things. I think we can call this B minus here. Yeah, I don't know. Okay, so this capacitor is shorted, and then we have these two resistors right across the line. What's R3? This is the volume control. It's going to have a high resistance. Yeah, 1 megohm. So no, you're not going to pull current through a 1 megohm and drop the supply voltage down. Besides, if you're knocking, this is the other thing too, if you're knocking 60, 70 volts off the power supply by wasting it on a resistor, that resistor is hot. Really hot. You know, all these regular size resistors in that kind of situation would burn up. Wow. Jeepers. Yeah, I don't know where to go with this next. I have to start interrupting the power supply and look for, you know, when I interrupt, like if I were to cut, let's say this wire right here, if I cut this wire and then the voltage goes up, then I would know the trouble is this away. The most likely place to do that would be this wire here, which basically is providing plate and screen voltage to these two tubes. But it's not supplying it. There's no components here. Well, wait a minute now. We come off here, along here, up here, up, keep going up here, and then we come back this way. So this is the plate supply to here. So all three of these tubes are getting their plate supply off of this wire here. On the schematic anyway. It could be wired differently in the radio. This wire doesn't necessarily exist. This is a line on the page. It's not necessarily a wire in the radio. I can't come up with any, you know, what to try other than cutting some of these wires if they do exist, or trying to find how to interrupt the output of the power supply. So what if I do that? I can find it here pretty easily, because basically it's one capacitor lead. It's the capacitor that does not have the power wire. Capacitor does not have the power wire, but has a wire leaving it here. That's the B minus, and a wire leaving it here. if I can find this wire, I could cut it, and that would disconnect the power supply, and then we'd see if the voltage rose up. It just seems insane. Well, of course it's going to rise up. Oh man, it's just, I don't see anything easy here. Oh my gosh. Yeah, I don't know how to approach this. Let's look at the possibility of opening one of these wires in here. Possibility of opening one of those wires. So you can see my video system, the frame rate has dropped way off because I'm in the dark here. I'm going to put on the light. Bring on the light. There we are. Much better. Well, so I'm just sitting here thinking, well, what if the capacitor that's connected right across from the power, from the B minus to the chassis, so what? If it's shorted out or something, I don't see the problem. So the two supply capacitors, here's one. This is the one I've hooked that has the power line coming to. So this is the input capacitor. Then we're going through the coil, which is up above here. And then we're going through the across the output capacitor, which is located up in here. So this would be the output. Where and is there a wire I can cut, or it's soldered right to the tube? Pin. Duh. Nothing easy here. There's nothing easy here. The situation really in my head is impossible. It can't be this way. But it is this way. Come on, coffee cup, you got to do it for me this time. So I've been studying the schematic here, looking for some reasonable explanation for why the B plus would be low, and I can't find any way to explain it looking at the schematic. So I'm going to show you what I've done here for a test, and I've never done anything like this before. No idea if this is really valid. Got this on ohm meter setting, and I'm just going to read right across the power supply filter capacitor, which is not a particularly good place to do this. I think the capacitor has no charge. You can see it's charging up from my meter is charging it up slowly. Probably charging both of these big capacitors up slowly. So even now, that's 300,000 ohms. So we're looking in at the rest of the radio. The power supply sees something like that, some hundreds of thousands of ohms. That's not going to pull the voltage down. So basically I'm looking for a short in the radio somewhere by checking the resistance the power supply is seeing or working into. And the resistance seems fine. I can't say I've done that kind of test with any kind of regularity. I don't really know what I'm doing. But I'm really left stuck here. What is wrong with this radio that it can only produce 30 volts? And I didn't hear an answer, so I don't know, really stuck. Okay, had a sip of coffee and an idea came to mind right away, and that is, well, what about this field coil? So the field coil is remnant here of the speaker. There's 4 wires going into the field coil. 2 of them are for the bulk of the field coil, and the other 2 is a humbucking coil. Let me show you this on the schematic. It's very subtle. So if we look at the speaker here, we see the output transformer right here, and they've positioned it on the schematic right next to the power supply. where we have the electromagnet. This is the electromagnet, and also field coil filter for the power supply. It's a dual purpose. It really, whoever first thought this up should have been, pretty good pat on the back for that one. So we look over here, we see the speaker cone, and we see a representation of the voice coil with wire coiled around it. Ooh, what's happening here? This piece is bigger than this piece. Why? And look, what's this square thing coming up here and coming down? And then look, there's a wire wrapped around here, but it's in a different direction from over here. So what's really going on here? This is the movable voice coil that's attached to the speaker cone and we're listening to. That coil is also attached to another coil here, which is on this core material. It's on the same core material as this. What's going on here is that this is called a humbucking coil. And the idea is a little bit of hum from in here, from in the power supply, is leaked into the speaker in a fashion that's in opposition to any hum that's come through the main radio. So there's a little bit of hum coming through, this will buck it away. But guess what? This doesn't exist anymore. This is gone, this voice coil is gone. The transformer that's in the radio may be the original one, the output transformer, but it may not. It may be a junk box transformer. And the original one may be gone. It went, yeah, I think we could probably make, you know what, I don't know what to say. So the wires that attach here are just in the open. They've just been cut and they're just hanging out. I showed them to you. Or did the guy get it backwards? And he's hooked up this as the filter to this. And these are the ones that he's left open. That would have consequences. But I don't know that he did that. I think whoever did the work was smart enough to avoid all that, would understand all these things and would know what they were doing. So I still don't know what is happening to the voltage here. I think I looked at cutting these wires. They aren't wires. These terminals are soldered right onto the tube terminals. And if we look up here, this is pretty confusing right in here. It's confusing right up until the point where I discovered that this terminal on this tube, this is the output tube, this terminal actually is not related to the tube. It doesn't connect to anything inside the tube. It's a spare terminal. Now this happens all the time in these radios. They have spare tube terminals and the designers use them to make connections. So they don't have to put in more terminals. They just use the spare terminals. Very confusing looking at the back of the radio for these things. And in this case, they've actually shown it on the schematic like this. Typically, they wouldn't show this terminal. They would just probably show this line coming right up to here or something. I don't know. They wouldn't do this. So all in all, what is going on here? You got me. So I am looking for how they're biasing this output tube, and I wonder, like this is the grid connection here. I wonder if all this is somehow generating. No, it can't. You can't create a negative voltage out of nothing. So I'm not really sure what they're up to here. I mean, there is a trick that can be played with the power supply where you don't ground it right off the capacitors. You ground it differently, put a voltage divider in, put the ground on the voltage divider, and you can produce a relative negative voltage. Maybe that's what this is, right here. Little voltage divider. I don't know. It's not helping the situation any, because none of that will explain why the voltage here is low. What am I missing here? There's this miswired. Okay, so if this is miswired, if this isn't working right, all the voltage is dropping here on this guy. can't I just check from between here and here? Why not? Check between the two negative leads. We should not have much voltage there. Check between the two negative leads. Okay, that's the plan. I got a plan. Is the voltage dropping across this coil? Did the guy do something wrong with this? Or is there another deal going on here? Okay, check it out. Let's check it out. Oh, what did I just hear? I heard a ding. Plug this in. Okay, get my voltmeter ready to measure DC volts. You know, we're looking for like how much? About 60 volts missing, was it? No, even more than that. Okay, then I'm going to practice now. Where, so the one capacitor there, the other one's up here. Negative is here, and the negative is here. So this essentially, am I really sure about that? I think so. So that should really be reading the voltage drop across that coil. Okay, I think I'm ready. Here we go. First of all, double checking the voltages on either side of the capacitor. I shouldn't read it. I should read it right across the capacitor. That's kind of interesting. Why was it just building up now? Took that long for the rectifier tube heater to heat up. So there's our 36 volts. Well, we should be getting like 100 and something. Now we'll read across the. I don't want to have my hand on the chassis. Where are you going, voltage? So 6 volts sounds normal. Some voltage is going to drop across the field coil. 6 sounds fine to me. If the field coil were dropping a huge amount of current, voltage, it would also be producing a lot of heat. And we have no evidence of that happening. No evidence of heat anywhere. Like if you were dropping this through a resistor, that resistor would be heating up. I mean, it would burn. In many cases, the thing would burn right in front of us. It would be gone. They would see it. You would smell it. Oh my gosh. The simplest thing in the world. Power supply not producing proper voltage. I just put another tube in. Just try another rectifier tube and just see. Regardless of the tube test. Oh my gosh.
7-game winning streak into tomorrow's game against the Vegas Golden Knights. It'll kick off a 5-game homestand at Scotiabank Arena. The Islanders, while the Oilers are home to the Kings.
Hey, where'd all that volume come from? Oh, I have this antenna hooked up. So what am I doing wrong here? You know, I think I've been reading the B plus to the chassis, and that's stupid. Maybe that's the mistake I've been making the whole time. I've been stupid. Maybe it's all it is. Okay, so I'm going to hook this up to the negative one of these capacitors. This would be the input capacitor. Let me just look at the schematic before I make a mistake here. We really want to go on the other one. Doesn't matter. I'm totally losing track of what I'm doing even. I have. I've forgotten totally what I was doing just now. I looked at the schematic and it somehow wiped my slate clean. B minus. That's interesting. That's an interesting number. That might be the bias for the output tube. Well, it's producing pretty good volume, but it's got a pretty good antenna hooked up to it. Can it work with this low B+? It's ridiculously low. Let me just double check. Output tube. Maybe I'm just totally nuts here. 600 volt DC. Output tube. There it is. There it is. There we go. 38 is what I got on that. How come we got 38? 39. 40 volts? No way. Wow, it's a very, very stilted video here today. Take this off here before. Yeah, I was going to measure. I'm going to measure here and get the 8 volts. This being the B minus, and the other minus. I read right across the other capacitor. Where are you, voltage? There's 100 volts missing in this radio. Yet it works. And the voltage dropping on these resistors. Nothing? Nothing? .5 volts. 0.5 volts. If we take 0.5 volts and grab a calculator here, say what happens if you have 25 ohms and 0.5 volts dropping across it. Ooh, that's easy. That'd be the same as 1 volt dropping across 50 ohms. 1 over 50. Can't do it any better than that. 1 divided by 50 equals 20 milliamps. That's just completely reasonable. Correct. Hey man, those 100 volts, they gotta be somewhere. I gotta change the tube. I gotta try a different tube in there. That's the only hope. Crazy situation. So I'm looking through my spare 35 Z5s. I have quite a few of them. Here's 3 of them here. Now, which one is not like the others? This one is not like the others. If you look in here, and I know this is hard to see on the camera, but the plate has that white area where like the black paint has come off. See, this one's the same. This one, no sign of that at all. What do you think? Do you think that's because these are high mileage and this one is lower mileage? Probably the case. I've got a bag of them here, and they're all in varying states like that. But I am going to test this one with a nice green check mark on it. We'll see. Now, I mean, the thing is, the last tube tested just fine too. Now, I think I've got this set up for 35Z5. Just a quick check so I don't embarrass myself. 07003. Yeah. Okay, let's pop this guy in. And we'll see how he tests. If he tests good, we'll stick it on the radio and see what happens. How this radio is working with 30 volts of B plus or 40 volts of B plus. It's really surprising to me, in fact. Okay, I know you can't see the dial. No shorts showing up. Test. She tests really good. Tests really good. Hey, let's just do that. While we're doing this, let me grab back one of those ones that looks really worn out. This one. So this one has a lot of what looks like wear and tear. Let's try it. Not just wear and not just tear, but wear and tear. Wear and tear. Okay, shorts in there. No. And how do you test? Even better. There you go. You see? You never know, but we're going to put this one in because it's nicer looking. 35Z5, no doubt about it. It's the correct tube. Put these here. Okay. Pop out the old one. So you know, wow, if this fixes the radio, then we really got to wonder what's going on with the tube that tests good but doesn't work. Okay, that's in. Now, if this, for some reason, produces B plus for the first time in a long time, the higher voltage may lead to some kind of interesting effect, like smoke and flames and stuff like that. Not very likely. Very, very unlikely. Okay, volume is set low, and here we go. Oh, voltmeter, get my voltmeter at the ready, because we want to look for the B plus. We're practicing, we're going to look for it right across the resistor here, right across the capacitor here. That's where we're going to look. Here we go. Drum roll. So we're going to run it with 100 volts, not full voltage. Okay, enough drum roll. Let's see if the voltage has appeared yet. You know, 40 volts again. Well, I'm not surprised. I really didn't think this would do anything, but we just have to do it to eliminate that possibility. Well, yeah. What's happening here? I'm going to do something really stupid. I'm going to measure the AC voltage coming into the radio. Why? It's actually not stupid considering the situation I'm in. Is all the voltage here? Should be 100 volts according to the little box there. Slip. Yeah, 109. Well, that's interesting. So this meter says it's 109. This thing says it's 101. Well, I would tend to believe this, for sure. In any case, it's there. Insufficient current flowing in the heater string, resulting in poor rectification by the power supply rectifier. Poor current flow would show up as heaters not being very bright. See, it's not just me. It's not just me who's not very bright. It could be the tubes. Now, how are we going to check that? I got to cut the power off while I tip this down, because I don't like doing that with the power down. Okay, we know this got pretty bright in the tube tester, and you know, just judging with my eye, that's normal. That looks normal. So that theory just went down the drain. It's a bad theory anyway. How would you have a restricted current flow in there? One tube has a heater that's gone way high in voltage, way high in resistance. I guess it could happen. Well, really totally stumped here. I'm stumped. I may have to end this video having not really made progress on this problem. In fact, I think that's what's going to happen, because it's getting a little late in the morning here. In fact, the morning is just about gone. Yeah, I'm going to have to just stop here. I'm not getting anywhere at the moment. Maybe if I give it 24 hours, some new ideas will come into my head. Maybe even some good ones. Well, thanks a lot for watching to this point. Don't know what's going to happen. Don't know what's happening. Good luck to me. See ya.